Start off by going over chapter 1. Oh, I had it up. I'll go through and highlight things that are important, and you need to write them down or highlight them in your book. First of all, I'd like to tell you that statistics has two meanings. One meaning is this meaning right here, the actual science of calculating and tabulating stuff, basically. Obtaining data, organizing it, and figuring out what it tells us. It's not probability. Probability works with statistics, and statistics gives us probability. So they work hand in hand, but they're not the same. So, of course, statistics, the capital S statistics means the science of collecting, organizing, analyzing data. So I need you to know that one. Could be tested on that. And we'll get to the parameters in just a minute, and that's the lowercase meaning of statistic. Make sure you understand what a population and a sample is. A good example of population would be Tri-County Tech students. A sample would be Anderson campus students. That would be a sample. If I wanted to make Anderson campus the population, then I would use this class as a sample. The sample is always smaller than the population, and you use the sample to predict the population. Why? Because of time and money. It's easier to survey a sample and cheaper to survey a sample than it is to survey the population. You see that a lot now with the polls, with the political polls. Short-term polls are effective. I've told all my students this. You can't do a poll for November between Hillary Clinton and Donald Trump when November is 6 months away or 5 months away. Or why? Well, Hillary could be indicted. Trump could get run over by a train. I mean, there's all kinds of things that could happen between now and November. So a long-range poll is worthless. But a short-range poll, meaning within the week, you know how they did the primary polls? They would, like in California or whatever, well, California is in a couple of weeks, but they would take a poll about a week before the primary. That is okay because that's short-term. But long-term polls, they're not really worth anything because, heck, we could have another, God forbid, we could have another terrorist attack between now and then. That would change a lot about the election. The stock market could crash. That would change the election. So a long-term poll is pretty much irrelevant. It's nice to put on paper, and it's nice for the people that it's for, but other than that, best just to stick with the facts. But that's what polls do. That's what you do. You survey the sample to predict the population. Now, with political polls and with our individual polls, it's not a big deal. But when you're talking about executive, when you're in an executive position and you're trying to predict the cost and effectiveness of the rubber at the Michelin plant, then it starts to hit at the pocketbook. And you get fired real easy if you don't know your stuff. So that's what the difference between population and sample. Here's lowercase statistic. Now, with statistics, we have formulas. And in those formulas, we have the mean, the standard deviation, the variance, and all that stuff. How do you know what's what? Well, we use parameters, meaning these are the things you use with a sample, these are the things you use with a population. The reason for this box right here, as far as statistic and parameters somewhere, they're going to talk about parameter. Just remember, S goes with S. Statistic goes with sample. Parameter of it, population is parameter, P and P. Let me give you an example of why you would need to know this, because it's not numerical, it's only knowledge. Let's say you're in a board meeting or you're in a division meeting. You work at the hospital and you're in a division meeting, and this guy, this person that works in quality assurance or some form of that with the hospital comes in and gives you a presentation on how well so-and-so hospital is doing. Well, he throws up mu, which is a big mu. It's a Greek letter for M. It's a big M-E-W, and it looks like a backwards M or something. Anyway, you throw that up there, and you throw sigma up there, and he does his presentation with mu and sigma and all this, and you're sitting there going, okay, that's the population. How do I know that? Well, because mu, the Greek letters, have to do with the population. Anything Greek letters in statistics is population. Anything regular letters, like S and X, that's your sample. So the reason you need to know the parameters for our formulas, or the variables for our formulas, is for knowledge. If you're in a meeting or somebody's giving a presentation and they throw up X bar and S, you know they're talking about the sample. If they throw up mu and sigma, you know they're talking about the population. And then you won't sound ignorant when you ask your questions. Is this the population? Yeah, it's mu. So that's why you need to know it. Nothing numerical. The formulas are the same. You just need to know which one you're dealing with. Awareness. So the only thing I want you to do there is know the statistic, lowercase. And parameter is somewhere. I don't know where parameter is, but you'll see it in a minute with, there it is. It's at the bottom of the page, right there. It is a variable depicting the population. So far, there's only about 2 or 3 things that we need to know, and I've covered them. Okay. First thing, you need to know what statistics uppercase means. Then you need to know sample and population. And then you know what the parameter of a sample is, a statistic, which means it's a letter, and a parameter for a population means a Greek letter. And somewhere they're going to talk about that being Greek letters and all, but you'll see it somewhere in the book. Okay. Qualitative and quantitative. You will be tested on that. Make sure you got that. That's on page 7. Qualitative data would be how many blondes, brunettes, and redheads like I have in class. That's qualitative data. How many people in my class have blue eyes? How many people have brown eyes? How many people have green eyes? How many people have hazel eyes? That's qualitative. Quality, not what? What's the old saying? Quality, not what? Quantity. Then quantity is quantitative. Quantity means numbers, means weights. Everybody's weights. Everybody's heights. Everybody's shoe sizes. Those are numbers. That's it. Just think about this. Qualitative is anything that describes you. Quantitative is anything that measures you. We go with what's the head size of everybody in here, and I'd have to go around with a measuring tape and measure everybody's head. That's quantitative data. Versus how many people in here have brown eyes, blue eyes, green eyes, and hazel eyes. That would be qualitative. Kind of stuff that you did back in high school, and I know that. We'll get to the challenging stuff before long. Discrete and continuous. I usually write on the board here, but a lot of people don't know the difference between discrete and continuous. Yeah, just come on in whenever, that's fine. Glad you got some lunch.
I actually have a class in Pendleton today.
I got here. I had a class.
Well, plenty.
I got here. No, I'm just kidding. There's always one I can pick on. All right. When you write discrete, I want you to put discrete out to the side, and then down here I want you to put continuous, because this is something that people have a problem with. And I'm going to write it on the board, and hopefully the board won't blow up like the one at Pendleton did. It won't work. I'm still getting people to work on it because doing all kinds of fun stuff. Oh my gosh, this one's doing the same thing. Not supposed to do that. That means I have to write with the mouse. The reason I have to write with the mouse is because when I write up here, when this is up here, that's in there, it's not recording. Can't steal power from us. Just kidding. And I can't turn it off. Well, that helps me out because now I got two rooms instead of I'll have to write with the mouse, and y'all make fun of my writing. I'll do the text. I'll text it. Sorry. Oh no, I gotta erase that. I can't erase it because this program is not on my computer. It's on the projector. Erase.
Did this thing called a smart board?
Yeah. No, actually, the problem is the projector has a whiteboard program in it, and I can't turn it off. And this is the second room where this is actually happening.
He's writing.
Yeah, but it's not recording. It only records when I'm running through here. This is in the projector. And I can't kind of erase it. There. Okay, it is good. Okay. See, this works. And it is working. Discrete. Yeah, it's writing terribly. So that means it's working. Because they're not supposed to put it on the board. They're supposed to put it. It's supposed to be on the whiteboard instead of the wall. And we told them that when they put them up, but they didn't listen. So the further I get to the right, the further it messes up. So I'll just do it this way. If I start on the left, it'll work better. Discrete. Remember concrete. And remember rational. Okay? Continuous. Remember, irrational. And this is a Hubertism, so I doubt, unless you've had me before, I doubt very seriously that you have seen this. Your irrational numbers are rational numbers that cannot be predicted. I'm sorry, can. Sorry. See, that's not supposed to go away. This is not paper. Can be predicted or located. Meaning that it's concrete, it's predictable, it's substantial, you can locate it on the number line without any problem. Whereas continuous cannot be. It is, it's recorded, so it's on my monitor, that means it's recorded. Cannot be predicted or located. Well, I don't understand here. Well, let me give you a list of numbers. 2.6. 3 halves. 1.44 repeating. 6 over 3. All right, all of those are different numbers. We got decimals, we got fractions, I will even put a whole number up there. All those are rational numbers. Why? Because you can predict the next number. In other words, this is 2.6 what? 0. You can predict it. This is 1.44. What's the next number? 4. This is 1.5. You know that's 1.50. You know the next number. This is 2. This is 4. You know that's 4.0. This is 2.0. So you know it's predictable. It's substantial. Down here, I'll give you 3 things. Pi, square root of 2, and the square root of 7. Now I want each of you to take your calculators and look at those numbers. Put all 3 of them in your calculator. If you don't have one, just look on with somebody. It's not that big of a deal. Don't go hammy on me and start shaking, all right? What? It would help to have a TI-83 because we use it a lot. I don't use it for you to do basic math. You shouldn't need to use a calculator for basic math. But for certain things, we use it. What's pi? Let's write down pi. I need somebody to go slow because I ain't no daggone computer. So pi is equal to 3.141597. 15397. What is it?
15926.
15926.
54.
54. Is that the end?
Yes.
Okay, somebody tell me what that next digit is. I have no clue. Why? There's no what? There's no pattern. There's no pattern to it. You know there's a pattern here. What's the next number here? 4. There's a pattern. You could do 1.12 repeating. And that's 1 point. The next digit is what? 2. Not 1, 2, but 2. You know the pattern. If there's a pattern, you can predict the next digit or the next series of digits. Any pattern goes here. This one, you don't know what that next digit is because unless you calculate it mathematically, which we're not going to get into, there's no way you can tell that next digit. All right, let's do the square root of 2. Somebody give me that one. 1.41. 1421. 3560. Okay, somebody tell me that next digit. You can't. And the same thing with the square root of 7. So, what in the heck does this have to do with what we're talking about? Well, what we're talking about is these 2 guys. Let's say that Now bear with me a minute. As we go all over the place, it's not staying on there. Let's say that there is a fire hydrant outside, and it looks something like that. And it's in a little area like a flower, like one of those medians out here, and where the trees are sticking up. And I ask y'all to go out and measure the height by bringing in a big old box, like that box right over there. Big old box of measuring equipment. What do you mean measuring equipment? Well, there's tape measures that you pull out, you know, the metal tape measures. And then there's, you ever seen a folding carpenter's ruler? Okay, got some of those in there. Got a yardstick. Got some of those cloth type tape measures. You pull them out, you reel them up. Got some of those. Got some that you pull out the metal tape measure and it has a digital readout on the spool. Got all kinds. And I tell each of y'all to go outside and measure that. She's out there somewhere. Measure that. What are y'all going to come back with? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 people in here. What will y'all come back with? Nope. You won't, because half of you can't read measuring tape for one reason. Okay? If you just graduated from high school, you probably can't. All right? There's other people that will say 15 and 3 marks. Those are the people, you know, that can't read. And then there's people that will read. And then there's people that'll just say, okay, well, it's 15 and 3/8. I'm just going to say 15 and a half or 3 and a half. So there'll be rounding issues. So I've got 16, whatever I said, 16 or 17 people in here. How many different readings am I going to get? 16 or 17. What is that? Is that concrete, or is it all over the place? It's all over the place. Okay? Let's go to the doctor's office. What do they always measure in the doctor's office, ladies? Y'all just love it, don't you? And then what happens when you go home? And you what?
5 pounds less.
Yes. I don't understand that. And then you call the doctor and say, I don't weigh that much.
I want you to change it.
I want you to change it. My scale says this. Is that concrete? No, it's continuous. Let's say that you're going organic, okay? All these people that are going organic. And you're going to have your own milk cow, and you're going to milk your own milk, and you're going to have your own milk. Whew. You don't know how much work is involved with that. But anyway, the whole point is you take your milk that you just milked out of the cow, and you pour it into a vat. And that vat is a gallon, measures a gallon. And then you pour it into another vat that measures 3/4 of a gallon. What's up with that? Well, volume is a measurement, just like weight and just like other measurements. All your measurements are what? What are all your measurements? Are they concrete or are they continuous? And so she got mad and left. See? I just do that all the time. What are they? Measurements are what? Continuous. Measurements are continuous. Why? Did y'all all give me one single height for that? No. But what if I told you to go out and count the fire hydrants in the parking lot? Yeah, you'd all get the same number. Unless y'all just are on some kind of medication or something and y'all just see stuff. Okay? Counting is what? Discrete. Now you're going to get 2 questions on this on your test. One of them says the height of if it says height, weight, volume, anything measured you're supposed to say continuous. It says the number of eggs in your refrigerator, that would be discrete. You count discrete. You don't count, measurements are continuous. However you want to word that. So the weight of a paperclip, continuous. Just remember the doctor's office. You could weigh 105 pounds at the doctor's office and then weigh 120 at home. Which one's right? The doctor's office. Right? And that's the difference between discrete and continuous, and I guarantee you'll remember it now. Is your driver's license correct?
Always.
Always, okay. Because that's what everybody got when they were in high school, right? And it ain't changed. Mine hadn't. It has, but it hadn't. All right, so hopefully that'll make that stick. Unless you want to memorize this. And if you want to memorize this, you're welcome to memorize that. How about this? The number of heads obtained after flipping a coin 5 times. Discrete. The number of cars. Ooh, what's distance? Measurement. That would be continuous. And that's 2 or 3 questions on your test. I want you to know, make sure you list these 4 things on page 10. Not a big deal, but make sure you know of them. And they give you some examples. Well, the old book used to give examples, but I don't know about this one. We'll see if it gives examples. Nominal means that there can be a specific order. Oh, does not allow. That's ordinal. Ordinal does. Remember, ordinal is order. Integral means that arithmetic can be performed. Ratio means that arithmetic multiplication and division can be performed. All right? Addition and subtraction. Think about temperature. Temperature. If I add 15 degrees to the thermometer, it'll raise it 15 degrees, right? But if I multiply times 2, does that mean that it's double? No. So where you need to remember that interval is addition and subtraction like temperature. But you can't do temperature with ratio because you can't multiply a number of degrees and get double or whatever the case may be. All right? Is this a test question? No, but is it in your homework? Yes. So make sure you know it for your homework at least. I usually don't test you on that. If I do, it's a mistake. And that's 1.1. Not a lot there except about 4 or 5 things. And I'll probably pull a little bit out of each section for your test, but most of your test, 80% of your test is going to come from chapter 3. So we're only talking about 20% right now. But I can tell you for sure that concrete and continuous, there's 2 questions on there because I remember putting them on there. Observational versus experiment. The only thing you need to think about here is sleep apnea versus the rat in the maze. You ever seen these people that have sleep apnea? They put them on a video with a night. They're green. There's green and you see yourself laying in the bed. I've seen them on the internet. I don't have sleep apnea. I don't have any problem after about a half a quart. Anyway, the whole point is, I'm kidding. The whole point is they you're doing an observation. You're watching these people while they're sleeping, right? And that's an observational study. Okay. What about a rat in a maze? A rat in a maze is observing until you put cheese in it. And then when you put cheese in it, are you affecting the maze? Yes, because they can smell it. They can, it's in the air. They can smell it. It messes up because they want to go to the cheese instead of the exit. Think about the placebo effect. That would be give each of y'all a red pill. I give half the class. That side of the class, I give a green pill. This side of the class, I give a red pill. And the people that had to take the red pill, they lose 10 pounds in a week. People that took the green pill, they lose 2 or 3 pounds. Okay? The green pill is a sugar pill. Red pill is actual medicine. Okay? They lost 2 or 3 pounds, but the only reason they lost 2 or 3 pounds is why? It's in their head that they were going to lose weight or something, whatever the case may be. A good example of the placebo effect is the Andy Griffith episode where the pharmacist, the lady pharmacist, Ellie, is introduced into the show, and she won't give Emma Watson or Emma Brand. She had 2 different names. That's a blooper, actually, in the Andy Griffith show. But anyway, Emma, she's an old woman that always has something wrong with her. But she comes by and she gets pills every week from the older pharmacist, and she puts a dime on the counter, and she gets her pills, and she goes home. Well, the new pharmacist, which is the pharmacist's niece, will not give her those pills because she does not have a prescription. Well, does anybody know what the pills are? They're sugar pills. And she takes them. She was about to die before she got her sugar pills, and while she was on her deathbed with all this food that everybody had brought her, she took her sugar pill and she felt better. The sugar pill, that is an experiment. Anything that you're having a part of the experiment or the part of the event, if you take part in the event, then it changes from an observation to an experiment. Now, why do you need to know that for this class? You don't. Other classes, you do. Especially in some of your labs. Some of you are going to be taking biology, chemistry, especially physics. If you ever take physics, you need to know where the difference is between an observation and an experiment. Psychology, oh my gosh, psychology, you do all kinds of weird stuff. And sociology, you need to know the difference between people watching. Is that an experiment or is that, well, if you work at Walmart and you super glue a $50 to the floor, that is a what? That's an experiment. All right? Not that I did that when I was working at Walmart. But when you do an observation, you just watch people like at the mall. I don't like to go to the mall, so I don't watch there. But I used to sit in my office in 315 in Oconee Hall, and I used to watch people. Back then we had this Marlboro Club that met downstairs in that little parking lot right there. And I used to just watch them people. I mean, some of them, it's just funny. I love to watch people. But anyway, that's an observation. But when you start taking part in it, and when someone put the dollar or the $50 down with super glue, you are turning that from an observation to an experiment. Okay? So that's a little bit there so you can remember the difference between an observational study and a designed experiment. That's not important. I'll tell you what's important and what's not. They give you some examples of observations and experiments. No, I don't test you on census. I think everybody knows what a census is. I don't talk about it that much, so I don't test you on it. Okay, I'm gonna have to zoom this down a little bit if y'all don't mind. Okay, random sample. Make sure you know what a random sample is. Random sample is what? This is a random sample. I take all of your names, first name and last name, I put it on a Post-it note. I fold the Post-it note in half, and I put all those Post-it notes in a goldfish bowl. And I fold every Post-it note the same way. That is a random sample. And I draw one name out of the fish bowl. That is a random sample. Why is it a random sample? You're right, but explain what random is. I didn't select it, but everybody has the same one. That's the definition of a random sample. Everybody has the same chance. How could I affect that random sample? By folding one of them 4 ways, and I'd pick that, or the person that draw it might grab that one and influence them to draw it, or influence them not to draw it. Remember, negative impact and positive impact is the same thing in statistics. If I reach in there and I draw, and I'm fishing around for one, and all of them are folded halfway except for one, then I may pick that one because it's folded a different way, or what? I may not. Either way, it's an effect. If there's an effect, the random sample is gone. And that's what you have to remember. See, a lot of probability and a lot of statistics has nothing to do with math. It has to do with the actual logic, has to do with the thinking. All right? Just like, for instance, was O.J. innocent or was he not guilty? He was not guilty. Yes, he was guilty of sin. I know that. Either he knew it or he did it, one of the two. But anyway, the whole point is he's not guilty. Well, what does that have to do with probability and statistics? Well, if he was innocent, he would never have shown up in what? Court. Because if you have an alibi, or somebody can establish your alibi, you're not going to be in court. Let me give you an example. Let's say Miss Martin works at Domino's Pizza or works at Bilo, and she got to go in from 5 to 11. And she drives up there, drives her car up there, parks her car, and her sister comes by and says, I need to borrow your car. Okay, she gives her the keys of the car. Her sister goes to the mall, whatever, goes shopping. Meanwhile, the car that her sister's borrowing, or her car, Miss Martin's car, gets stolen and commits a robbery. And while they committed a robbery, they shot one of the security guards, dead. They find the car. Oh my gosh, Miss Martin robbed the bank and killed somebody. All right? Why isn't she going to court? She works at Bilo, so she has at least a boss or a supervisor, or she got cameras, and she's got the eyewitness of somebody that took the car, and probably her sister called, the law whenever that car was stolen. So there's no way she's going to court because she's innocent, because she can establish an alibi. The people that go to court are the people that cannot establish what? What could O.J. never establish? His alibi. He never could establish it. That's one of the reasons he went to court, because he couldn't establish an alibi. So that's the difference between innocent and not guilty. Now that plays in to a lot of our stuff, because there's one of the problems that we're going to be doing in the future with the roulette wheel. And to win on the roulette wheel, you need to hit an odd number. Well, the rest of the numbers, you don't say even, you say not odd, because there's 2 numbers on there that are either odd or even. So you have to say not odd. You can't say even, because if you say even, you come up with a different number and it's wrong. You got to say not odd. So in a lot of my writing stuff down, you're going to see me put probability of 15, and then I'm going to say probability with 15, and I'm going to put an X through it. Because you can't say the probability of 29 or the probability, you have to say not 15. We'll get into that later. But anyway, random sample is a difference between, everybody has the same chance. Okay? I try to give you a little bit of a story behind every definition to try to help you remember the difference. Simple random sample basically has to do with a little bit of grouping. Let me tell you what the difference is, but I'm not going to test you on simple random sample. A simple random sample is basically, this table is group A, this row is group B, the third row is group C, the fourth row, no, y'all ain't in class. The fourth row is group D. I take 4 Post-it notes and I put group A, fold it, group B, and then I put them in a goldfish bowl, and I pick one. That's the difference between a random sample and a simple random sample. Simple random sample is grouped. But I'm not going to test you on that. I'm just going to test you on random sample if I test you on that. Okay? Good gracious. And that's 1.3. I think we go to 1.4, don't we? I just ain't gonna talk to me like that's okay. All right, different ways of sampling. They usually give it to you all in one. I don't like this book. Hold on, I'm looking for the page. It's got all of them on one page.
1.4 gets into formulas.
Gets into what?
Formulas, I don't know what you call it. Stuff that makes my neck hot. Like actually.
Makes you think.
Yeah. Exactly.
Hold on, I'm getting there. There's supposed to be a there they are. All right, we talked about a random sample. This ain't what I'm looking for. Shoot. This is not what I'm looking for. That's why I don't like this book. Okay, let me go back. I don't really get into stratified. Stratified is when they're talking about grouping. I don't get into that. When I get into systematic, and I'll test you on systematic. Systematic is every 7th person in the phone book, every 3rd person in the class. So I count 3 people, 1, 2, 3, you're yellow group. 1, 2, 3, you're yellow group. 1, 2, 3, every 3rd person is in the yellow group. Every 2nd person is in the blue group. Every 1st person is in the green group. All right? Every 3rd person, I'm going through and picking every 3rd person. That's a systematic sample. You go through and you pick every 4th person in the phone book, and you call them up and survey them on this. That's a systematic. Systematic, there is a what? A pattern. The computer goes through and picks every 15th person in the phone book. That is a systematic sample. Convenient sample. Convenient sample is the least accurate, least used. Why? Because it's what? It's convenient. Convenient sample. I'm a student, and I'm a Math 120 student, and I part-time, when I'm not going to school, I work at a rock radio station. So I'm going to do my project on how many people listen to rock music. So I work on, and I get the DJ to say, okay, we're going to have a 1-hour call-in. Everybody that loves rock music, call in. That's a convenient sample. What's wrong with it?
Asking a rock station.
People that are listening to a rock station usually what? Love rock music. So it's no good. And some people say a convenient sample is shouting out the window or going out to the... Now you could go out to the parking lot and you could do a convenient sample there because you're here. Now that would be a good convenient sample, depending on if you're asking whether you like Pendleton or not. Well, not many people like Pendleton because they're coming to the Anderson campus, or it's closer to their house or work. So that's why they're here. So that would be kind of, the convenient sample wouldn't work there either. So convenient sample can be used, but it's in the context of what you're looking for. You got to watch it because it can be biased because of the convenience. Okay? A cluster sample is basically what it means. I like to think of a cluster sample as precincts, voting precincts. That would be cluster samples. Why? Because within Anderson County, there's like 46 or 72 voting precincts. I can't remember how much there are. So you can divide Anderson County up into those groups. That's cluster. Actually, stratified would be Democratic and Republican in each precinct. It's a mini group in a group. That's what stratified is. But a cluster sample, just think of voting precincts. You could think of counties in a state. That would be like a cluster sample because everybody fits in a part of the state. A cluster. I don't test you on those. I might test you on systematic and random, but I won't test you on any of the other ones. But it's nice for you to know in case you go into a lot of these terms and a lot of these things that we're discussing now will be used later if you ever go into a Math Science 301 at Clemson, which is their basic statistics at Clemson. That's where most of these things will be. You'll hear them and say, oh yeah, I remember that. We talked about that. It's so you won't be blindsided by some of these terms if you go into another statistics later on. Oh, that was convenient sample. Okay. Convenient sample. And that's 1.4. And then we shoot over to 2 point something. Correct? Somebody tell me what page 2.1 is on so I can shoot to it and not have to go through it.
64.
How much?
64.
Thank you.
I'm sorry, 62.
Okay, 62. Students want to give me bad information. Set me up. All right, what are we talking about here? Organizing qualitative data. I thought we went through 2.4. We only go to 2.3? I guess so. Look in your outline, but I thought there was 2.4, but I could be wrong. Okay. Okay. This is right. Frequency distribution. Now that, put stars beside it because you need to know that term, because this is the area of statistics that people do not usually, when they're in high school statistics, they don't address it very much. Okay, I'm just telling you. Some high schools do, some don't. But basically, it's a head count. How many A's we got in the class? How many B's we got in the class? How many C's we got in the class? How many D's we got in the class? How many F's we got in the class? It does not list. There's two types of data in statistics. There's your test grades. Okay, 42, 58. 107, 76. You got 5 or 6 test grades. You add them up and you divide them by the number of test grades, right? That's how I call that data driven. In other words, you've got 5 or 6 grades. And then there's the frequency distribution, which doesn't look at you individually, but looks at what? The whole class. And puts A, B, C, and D, and then you have a head count. All right, based on those averages that you can do with data driven. So you got two forms of data, data driven and frequency distribution. You still need to find the mean and the standard deviation for both, because the mean and the standard deviation generates a lot of things in statistics. Those are the two most important numbers you can calculate, the mean and the standard deviation. And we're going to get to that in just a few minutes, but I don't know if they're going to bring it to you that quick. That's all in chapter 3, I think. But we'll see. I don't know in May. I'm not used to this book. Haven't got used to it yet. So here's an example. Just take out the tally, but what body parts? I don't know. Physical therapist wants to determine types of rehabilitation required by our patients. So back, she's got 12. Wrist, she's got 2. Elbow, blah 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 blah. Now, if you wanted to get a mean and a standard deviation of this, you could, but we'll get to that in a little bit. I just want you to know what a frequency distribution is. It's a table of a head count. Now, the relative frequency is basically just a percentage. Now, can somebody tell me what they remember about percentages as far as a fraction goes. How do you get the percentage? Divide, exactly. You divide by the whole number or by the big number. So, if you've got 12 back patients, then you divide that 12 by the total number of patients. And she's got 30 patients, so 12 divided by 30 comes out to be 0.4. And you multiply that by 100 and you come out with 40%. So 40% of her clientele is what? Back patients. And that's right there. That's called a relative frequency. Most people call it a percentage. But in here, you hold your pinky up and you call it a relative frequency. It's all about putting on airs. Call it a percentage in real life. Yes, ma'am. Oh, I thought you were asking a question. She's trouble, isn't she? All right. So there's all the percentages right there. 2 divided by 30, 1 divided by 30. Please don't calculate 2 again because it's the same thing. And if you add all those up, you should get 100% or 1 since it's decimals. And that's how you do a relative frequency. Relative frequency of a frequency distribution. Percentages off the table. So we did blonde, brunettes, and redheads in here, and we had 1 redhead, that would be 1 out of 15. And then 3 blondes, that would be 3 out of 15. And then the rest, dang old 11, would be 11 out of 15. You divide it, and then you multiply it by 100, and that would be your percentage. A bar graph. Go ahead and put histogram versus histogram out here. The difference between a bar graph and a histogram. Does anybody know the difference?
Don't the bars touch?
Yes. The bars touch on a histogram. They do not touch on a bar graph. That's the difference. Is it a big deal? No. Do I care? No. It's not that big a deal. So I just don't want you to get confused on the major differences. There is no major difference. This is a bar graph because there's air between the bars. If you squish all them bars together, you've got a histogram. If they're touching each other, it's a histogram. Don't ask me. But as you can see, how do you do a bar graph? Well, you could do a bar graph. You could now let me explain this. And it's on video, okay? When I use Excel in class in 120, I use it because it's good at organizing stuff and it's good for y'all to see because I write all over the board. Okay, so I use Excel when I'm not doing math on the board. I use it because it presenting. Okay, don't be going home tonight saying you got to use. I'm not saying anybody has to use Excel. I'm just using it for me. So I can go through Excel and I can put, you know, we could say blondes, brunettes, brunettes, and redheads. And the reason I use blonde, brunettes, and redheads is because it's 3 things. It's real simple. I don't use eye color and stuff like that because then my eyes are not hazel. One of my eyes are gray and the other one's blue. Shut up. All right, and this is head count. So we said a while ago we had 3 blondes, 11 brunettes, and 1 redhead. I don't even know how many. I just made those numbers up. Okay, then over here I'm going to go relative frequency with my pinky up, and that's going to be 3. Let's see, is that 14 people or 14, 15? So this will be 3 equals 3 divided by 15 and equals 11 divided by 15, and then equals 1 divided by 15. And then if I wanted to call it a percentage, that's the decimal form. If I want to call it a percentage, I could type right. There we go. I just take this and I take equals this and multiply by 100, and there's your percentage. All right. But what if I wanted to do a graph? Well, if I want to do a graph, I just do this right here. Go up here. I'm not used to. Give me a second, because I'm not used to. Where is it?
Maybe the insert.
I thought it was insert, but I didn't see it. There it is. I'm sorry, I missed it. All right, you can go hit this, and I like the 3D. Wow, look at there. That is a bar chart. If I was to squish this over here beside this and put this beside this, it's a histogram. Okay? So that's that. And I would encourage you to try to use Excel, because you're going to find out that Excel and your word processor, Word, are the two major things that you're going to be using in the future. Not as a student, but as an employee. Unless you're not working with computers, and then that's something totally different. Okay? So get used to it. And I'll pull that up when we start doing mathematical problems. I'll use that. So the reason I use it is so all the numbers stay the same height and the same, so I don't write all over the board. That's why I use it. Okay? Oh, I'm sorry. I was on this and pulling up there. Okay. I don't know where that came from. Okay. Pareto chart I really don't use, so you can write it down if you want to, but I won't ask you to do that. Pareto chart, a little bit different, but it's based on the what? Instead of the head count, it's based on the what? The percentages, or the relative frequency. That's the difference. So if you wanted to make a Pareto chart out of the one we just did, then you would put 0.2 right here, 0.73 right here, and 0.066 right there. There it is. That's a Pareto chart. Change it back. There. Oops. Sorry. Like I said, this stuff's not hard. Just a lot of definitions and a lot of thinking. You got to think a little bit. A pie chart is very important. Make sure you know how to make a pie chart. Well, I'll show you how to make a pie chart. Go through Excel. You highlight these guys, and you make a pie chart. And that's basically how I'm going to ask you to do it. Well, don't hit that one, hit the pie chart, dummy. There we go. There's your blonde, brunettes, and redheads right there. And of course, you can make it as big as you want. Doesn't matter. It's going to print out on 8.5 by 11. As long as you tell it to. There you go. If you want to add stuff to it, you go over here and hit the, hold on, I got to find it. And data labels. You can add that, or you can add, that's the head counts. You can add to that by putting it outside, inside, wherever you want to. There we go. You do that. All kinds of neat little things you can. That's why CPT 170 is so important. If you've had CPT 170, they should go into this more in depth, and you can actually utilize Word and Excel. It's kind of like using 100% of your brain. We only use like 10% of Excel and Word. We don't use 100% of it. It just about do everything but write it for us if you used all of it. So Excel's the same way. There's all kinds of neat stuff you can do with Excel. Okay? But that's how you can do a bar chart, a pie chart. I'm not going to ask you to do it by hand. That's not detrimental. But make sure you know how to calculate, like right here. If 2,700 students was, or let's say 2,700 or 2,000, let's go with 1,000. Let's say 1,000 students was graduating right here. How many will go on to get a bachelor's degree? 190. How many will get associate's degree? 90. How many will do some college? 170. Because you take 1,000 and you multiply it by what? 0.17. Okay? Or whatever the case may be. 1,000, yeah, 1,000 multiplied. Move it 3 places, that'd be 0.17. 1, 2, 3. Be add 0, it'd be 170. How many will just use their high school diploma? 310. How many didn't even get their high school diploma? 130 out of that 1,000. Okay? So anyway, that's a little bit about that. Make sure you know how to calculate. And again, most of this is your pre-algebra questions that you have to have in algebra. You should know how to read a pie chart. I mean, that's pretty self-explanatory. Could you see a pie chart or a bar chart on the test? Yes, you could. Maybe one question, but it's not that detrimental. Okay? And it's not how to make one. It's basically how to calculate off the way. And that's 1 point, whatever that was in, we were in. Let me see what the next section is. 2.2 will be next. Did we get there? Organizing qualitative data. Okay, here's an example. We'll just look at it. The manager of Wendy's fast food restaurant wants to know the typical number of customers who arrive during the lunch hour. The data in table title. Make sure you can read when you take this class. The data in Table 8 represents the number of customers who arrive at Wendy's for 40 randomly selected 15-minute intervals of time during lunch. I'm trying to understand that. The data in Table 8 represent the number of customers who arrive at Wendy's for 40 randomly selected 15-minute intervals. Okay, I see what you're saying. So like, okay, that would be from 12 o'clock to 12:15, 12:05 to 12:20, 12, I see what they're talking about. For example, one 15-minute interval, 7 customers arrive. Okay, so these are the intervals. So they want you to organize that in a data set. Okay? So first thing you would do is put them in order. You need to put them in some kind of order. I think that's what they did. And then you count how many came in that period. Okay? So you would go through and put them in order and count how many 6s there are, how many 5s there are, how many 4s there are, and that's what they did. How many 2s are there? Well, let's go through. There's 1, and there's 2. So there's 2 2s, or 6s. There's 6. I'm sorry. 1, 2, 3, 4, 5. There's another one in here. 6. There's 6 of them, and that's what they're doing. And then once you find that, relative frequency. It's best to put them in order, because when you put them in order, you can find them all. And the good thing about the homework is, when you go to your handy dandy homework, and 2.2. Trying to go there. So she's getting discouraged and leaving already. She's quitting. Study plan. Let me pull one up, see what it says. 2.9. Let's pull up 2.9. Don't want that. No, I want them to show me. I guess, okay, they already. No, that's not what I want. That's not what I want. I'm looking for a certain problem. If you'll just, okay, here we go. Let's see, this is it. No, they've already done it. Well, anyway, you'll find a homework problem where they want you to make. Okay, here we go. This is what I'm talking about. No, it's not. Usually they give you a bunch of numbers and you're supposed to find like this. All right, this is the problem we just did in the book. See that little tab right there? When you hit that tab, little tab right there, you can put it in your Excel spreadsheet. And then you can just put it in order. See? And now I can just highlight this and go to data and dang old, put it in order. Now it's easier to count. Everybody see that? I'm going to make it bigger where everybody can see it. See, it was like that. Oh well. Hold on. It was not in order. There. Now let me blow it up. Okay, now I just highlight the column. Go up here to data and hit the A to Z. And see, it puts it in order, and now you can count them. The number of ones right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you would put 12 right here. So that's a good thing. When you see that little tab right there, that means, all right, I don't have to type all this in, and I don't have to put it all down in my calculator. I don't have to write it all down. You just put it in your Excel spreadsheet. Okay? So that's a good thing. Go back to the... So that's what they're doing here, except they don't have it where you can put it in a spreadsheet. You have to do it by hand. And that's what they're doing. There's the histogram. Here's an histogram. So the difference between a bar chart and a histogram, the histogram is on page 79, and you see that it's no different. It's just touching. Not a big deal. Same thing. Organizing data, that's not a big deal. Organizing data. We're getting closer to chapter 3, so we're getting closer to the math and 80% of your tests. So just bear with us. Okay, class width. This is where we start getting into a little bit of the stuff we need to find in chapter 3. You got to have the class width. What is the class width? Well, the class width is the width of each class. And what I tell students to do is count it. Okay, let me find a good one to go by first. Hold on. You can use that formula. That's fine. You can write that formula down. But the easiest way to tell the class width on one, and usually they're whole numbers, so you don't have to worry about it. I'm trying to find one. Just give me a second to find one. find one in the homework. I'm looking for a frequency distribution with classes. There we go. Well, that's not the one I really like, but we'll have to go with it. This one right here. What is the difference between 775 and 800? That's your class width. What's the difference between 8 and 825? Class width. 825 to 850, 25. So after you take away these two, or take away these two, or they have to be consecutive. You have to take this one away from this one, or this one away from this one, or this one away from this one. You can't say 775 from 824. You can't do that. But just go down this. Every one of these. What's 950 minus 925? 25. 25 is your class width. And that's how I find the class width. Okay? So just subtract those two numbers right there, and that's your class width. So the class width here is 3 minus 2 is what? 1. Class 1. The class width here is 1. And that's how you find your class width. Class width, somewhat important. It works in some of our formulas, but mainly the midpoint. The midpoint is what we need to know, and I don't know if they teach you that in chapter 2 or 3, but we'll get there eventually. But that's what the class width is. The class width is the lower class limit of the second value minus the lower class limit of the first value. That's basically what it is. We talked about histograms. That's just a bar chart, modified bar chart. Stem and leaf. Again, this is a stem and leaf right here. What is it? Well, you got to put your data in order and find your lowest number and your highest number. In this case, our lowest number is around 7, and our highest number is around 20 up here in this data. So the lowest number is 7, the highest number is 20. And then you put what's representative of that 7 out here. Well, let's find the 7 up here. There's only one 7, and it's 7.4 right there. So the 0.4 is right there. So you can read this as 7. The line represents 0.4. There's one instance. What about the 8? Well, let's look. Let's go. There's 8.2 and 8.6. So there's two representatives of 8 in this data. 8.2 and 8.6. 9, there's a bunch of those. There's 9.9. You've got to put them in order. Here's the representative 9.9, 9.1, 9.3, 9.2, 9.7. They're not putting them in order, but you can. Okay? Let's go to 14. Well, where's 14? 14. That's why it helps put them in order so you can find them. There's one representation of 14, and it's 14 point what? 4. And that's how you do a stem and leaf. Now, what if these were whole numbers? If they were whole numbers, let's say the lowest number is 7 and the highest number is 20, then what if I had a 21 up here? And that would be 20, and then what would be, instead of the 6, it would be a 1. Like that. Okay? So that's how you do a stem and leaf. So if we had, where is the stem and leaf? Let's see, where is this one? Example 8. All right, let's look at this value right here. I'll blow it up for you so you can see it real good. Well, that's as far as I can do it. Now let's move it over a little bit. Do a stem and leaf for this one right here. Now, it'll take you a minute or two to get it in order and then count what you got. But find your lowest number. I see 3.2. Looks like 3 is your lowest number. What's your highest number? I see 11, 12. Is there a 13? So it looks like to me that your lowest number is 3, so that would be at the top. And then your highest number, which would be at the bottom, would be 12. And then you draw a line. Huh? Yeah. All the way up to 12. And then find your representatives of 3, 4, 5, 6, meaning the decimals. And put them out to the side. If you want to put commas beside them, you can put commas beside them. I'm looking at 3.2. It looks like there's 2 of them. So that would be 3 with the line and then 2, comma 2. There's 3 of them. Okay, thank you. That's why you got to put them in order. Okay, and as you can see, that gives us, if you didn't put them in order, that's what it looks like. If you did put them in order, that's what it looks like. Now, what does a stem leaf tell us? Well, it kind of tells us in the previous problem that we did, or the previous problem that was done in the book. Let me find it for you. Not that one, but this one. except for a couple of dips. What does that kind of look like? The normal curve. But it's not because of these dips. It kind of really goes up, then down, then up, then down, then up. But you start to see a little bit of the normal curve right in there just by looking at it like that. You start to see it. And you can tell if it's a normal distribution by the stem leaf. You can just put it on its side. This one's not because of the dip here, the dip here, and the dip here. Well, the dip here is okay. These two dips kind of mess it up. But you still see partially a normal distribution. Okay? And in your problem we just did, you see that there's not a distribution there either. Because all your values start at where? The left side. See? And if you apply that, it should be in the middle. So if this was a test, I would say the test is not valid because the test is too hard. Why? Why is the test too hard? Because all your data is where? If your mean is 70, all your data is below 70. So what does that tell you about the test? That everybody's stupid, or the teacher sucks, or the test is invalid, or a combination of all three. That's why the class average is so important when you take a test. If you take a test and the class average is 42 and you make a 36, then that's palatable. It tells you that the test is not valid or the material has not been taught. I don't care who sugarcoats it. That's what it means. If you take a test and you don't have a 70-ish average, then something's wrong. Something is wrong, period. Because 70 is the average, usually. 70-ish, 65-ish to 75-ish, somewhere in there. If you get like 42 or 6, the test is invalid. Or the class sucks. And you're not going to have, because the old rule, Hubert's rule, I got 3 or 4 rules of life. One is there's always one. There's always one person in the class that's what? That's going to screw it up. Whether you're on a field trip to El Herrero's or whether you're taking a test, there's always one student that's going to score 105 on a test that everybody else won't. Always. Unless the test is really invalid. And then you got a leg to stand on if the...
Do you have people fail your test?
Huh?
Do you have people
Oh, yeah.
fail an online test?
Yeah. They don't take it, or they just take it 3 times, and the most they make is a 50. Yeah. Those are the people I tell students, if you ever meet somebody that's failed my class, kind of move away from them real quick, because the lazy or the stupid might rub off on you a little bit. But I cover the material so well that everybody makes good grades. No.
Question?
Yes, ma'am.
The homework that you assigned, if we don't go over that section in class, do we have to do that homework?
No. Because did I skip something?
No, you're fine.
No, I just wondered. But yeah, that's right. If I don't cover it, and I do skip sections,
Right.
like Unit 4, if we get to Unit 4, it'd be very unusual. I usually don't make it to Unit 4. But if we do get to Unit 4, I may skip the last 5 or the last 3 sections. If I don't cover it, you don't do it.
Okay.
So don't go ahead. That's why I only let y'all are only able to do Unit 1, because some of y'all will go ahead and I skip the section, and you get mad at me because you went ahead and did the homework.
Yeah, like 1.5 or.
Yeah.
You're right. That's all me.
Okay. I'm
So
just.
we're supposed
that's
to
what I
have
was-
1, 2, and 3, don't we?
After today, yes.
Oh, after.
I just wanted you to read today. I mean, from the last class to today, I wanted you to read through. And if you did them, that's fine.
Do we get a sticker?
Huh? No. You're still going to fail class. All right. I make sure of that, especially if I don't like you. All right. Where's my... This thing is not working right, people. Okay. There's two of y'all in here now that's going to fail. One keeps picking out stuff and giving me wrong answers. The other one just wants to move ahead and try to pass me. So, all right. Dot plot. I'm not going to go into a dot plot. People, what does a dot plot look like? It looks like a bar chart. I'm not going to sit here. The reason it's got one of these is because there's only one representation. There's 1, 2, 3, 4, 5, 6. Okay, I'm not going to insult your intelligence by saying, okay, y'all need to study this. I think y'all can understand what a dot plot is. Okay, here's your, you need to know these 4 things. Now, you need to know it because when we get into averages, you need to know uniform. When we get later on, bell shape, you need to know that. Here's an invalid test. And what is this one? It means it's too valid. Okay, because the average, let's say the average is 70, everybody is what? Passing the test. Okay? So that would be invalid. Let's say the average on the test is 92. That's not good. Okay, why is it not good? Because everybody's not that smart. Okay? Usually the average should be around 70-ish. Unless you're just an exceptional class and I'm an exceptional teacher and everybody has a high average. Yes, sir. Oh, I'm sorry. There you go. And that's why a normal distribution, that's what a normal 70-ish, 70 would be right about here if you were doing a test. Remember, these are opposite. Skewed right is when all the data is on the left. Skewed left is when all the data is on the right. And you just need to know these. You don't have to draw the blocks. Just draw the curve. You don't have to draw the blocks. We get into uniform and normal distribution a whole lot more in chapter 6 and 7, I think. Okay, it's 10 after. I need to quit. I got to go pick up my son. Let me go ahead and call the roll today. DSS outside with my son not picked up. Shivering, cold, wet. Huh? Yeah, neglected. There you go. Oh, I got to turn off the recorder.